Welcome to Lab 4 Oscillations. The purpose of this lab is to examine the motion of a mass attached to a vertical spring oscillating when the spring swings in an arc, and then relate the observations and the computer model made to the energy principle. The observed data from the tracker and computer model are very similar and agree with the energy principle. Some key concepts are Newton's second law, which states that an object in motion will stay in motion, and the formula is net force equals mass times acceleration, which then we can derive the momentum principle. Delta momentum, is equal to the net force times the change in time. Using the variables definitions, we can manipulate this law to compute expected velocity or position, like with the position update formula and velocity update formula. Some more key concepts are the spring force in oscillation, where the force of the spring equals negative Ks, where S is the difference between the compressed and stretched length of the spring and the relaxed length of the spring. And the spring force is a non-constant force. We can also find the time period of an oscillation using the equation the time period equals 2 pi times the square root of m over k, where k is the spring constant. The last key concepts are the change in energy, which equals to the external work done plus Q, heat loss from the surroundings. And depending on the choice of system and surroundings, it equals to change in kinetic plus the change in potential. Next is the work performed by forces in the surroundings and is given by work external is the work performed by forces in their surroundings and is given by work equals force times displacement. Q is the amount of heat gained. But for this lab, we're only using kinetic and potential energy, and the external work is 0. Lastly, the only energy present in the system is kinetic energy translational, the potential energy, gravitation, and the spring potential energy. And here are the formulas. So the experimental design, we're using the pre-lecture video given. The system is a spring mass earth system, and the surroundings is nothing, meaning that we can set the external work equal to 0. And initially, the mass and spring are motionless. The mass is 0.402 kilograms. The initial position is given, and the spring constant K is 6.83. The relaxed spring length is 0.123. And you can see on my math in the next slide, this is how I got the spring constant using what we were given and the relaxed length of the spring. Here's the tracker video. So with this video, the attachment point is clear and there's a clear image of motion. We used the frame 0 for a calibration, but then we began our analysis from frame 6. So here's the tracker analysis taken. The X and Y positions were taken, but not the time. Here's the computational model. We put in all the constants and the K value and the relaxed length of the spring value that I solved for, and then using all of the physics principles, we could calculate and code what the equations were. And here's a continued, where this is the calculation of the energy changes. Next is the computational model, and here are the results. So as you can see, the total energy is a straight line, which is what it should be. The change in potential energy of the spring is inverse to the change in the gravitational energy, and delta K is oscillating. Everything is oscillating. And as you can see, the results for the X position for some time in the model and the experimental values and the Y position in time were very close. Some sources of error. I didn't account for any external forces like an air or a breeze in the video or any air resistance. And there was possible human error present because of the video quality, and we also didn't account for any other forms of energy loss like heat because they are so negligible. Conclusion. Is the energy principle satisfied? Yes. There is no work done externally. The total energy is 0, which is consistent with the orange line in the graph, the total energy being the straight line. Since the mass slows down as the video plays, the kinetic energy decreases, which is consistent with the blue line, the kinetic energy line in the graph, as it changes from positive to negative, as the velocity changes from positive to negative. The potential gravitational energy and potential spring energy are inversely related, and they oscillate within the same time frames but in opposite directions. So the periods can be extracted by observing the time differences between two minimums or maximums The x period is 1.64 and the y period is 1.53. They are different because the mass is moving in two different directions with two different behaviors. In the y direction, the mass is moving like a spring, but in the x direction, the mass is moving like a pendulum. Thank you.